So, task 29. And I was wondering, should I call this task at all? And I decided yes, because reflecting and marking your work is important. So, what is task 29? We're going to just go through questions. I'll provide you the answers and maybe a bit of commentary here and there so you can mark the work you did in task 28. You were asked to do questions 2, 4, 6, and 8, and then 11 to 17. And you should have had access to the PDF on that. So for question number 2, there was the listing, all the 16 probabilities. So you have the probabilities there to mark your work. Part B, what was the chance of getting an A twice? So getting an A twice, there's only one way. If we look at it there, there's only one way to get an A twice out of a list of 16. So 1 on 16. What's the probability of getting an A at least once? Getting an A at least once, you're looking for every listing that has an A, whether it's the first A, the second A, or even this case where it has both A's. So 1, 2, 3, 4, 5, 6, 7. So 7 ways to get an A. That's how we came up from 7 16. You were looking through to find which of these listings, which of these combinations had an A. Both letters are the same. You have AA, BB, CC, DD. So in other words, the answer was 4 on 16 and 4 on 16. So 4 on 16, which could be simplified to be a quarter. That's where that's coming from for B. And for part 4, the letter B is not obtained at all. You're looking for all the options that did not have a B. So once you had that, all the listings, which ones didn't have a B? That was, and there's 9 of them, so 9 out of 16. For question number 4, I'm looking at question number 4 now. The red spinner, and we were asked to draw a table of all the possible outcomes. So that's the table you had there of all the possible outcomes. And you know what? I can just bring in that's the question we're looking at there. Remember, the issue was, yeah, and Zoom was getting all these questions, the questions particularly from 11 onwards, to actually fit on the screen. That was the big issue. That's why I gave you the PDF. But you know, if it is that you haven't got something right and you want to just check it over quickly, go back, hey, what was the question? You know, okay, it's all up in the video. I'll have the questions in really small. I'll just drag them in as we quickly go through the answers. So that was question number 4, and you can see, well, question number 2, if you wanted to look back at it, that's question number 2 there. Can I get 140%? Maybe. No, not happening. Yeah, I could. Yeah, 140 would work there. So yeah, so you can see the question there. And right, so number 4 is what we're looking at, and I'm just going to make some commentary as necessary in terms of questions here. So for part A, you wanted to draw a table of the possible outcomes. That's the table. Remember, you were adding, was it adding? Yeah, the 2 scores are added together. So 1 plus 1 gives me 2. 3 plus 2, that's what we're looking at there. If I have 3 and I add 2, I'll get 5. So these are all the summations here. And then you were asked probability of an even number. The probability space, the number of different outcomes in all cases, it's 5 by 4 grid. So you have 20 possible outcomes, which they actually told you. So your starting point in all of these questions would have been having fractions with a denominator of 20. And then an even number, you would have had to count how many even numbers. And the probability is a half, which means you had 10 even numbers. For part 2, the number 7, you were counting how many 7s, and there were 3 7s here. So that's why we have 3 out of 20. A number greater than 4, you're counting all the instances of number greater than 4. So all the 5s, 6s, and 7s, 8s, 9s, 5, 6, 7, 8, 9. Just going across each of these diagonals, you're totaling them up. That would have given you 14 options. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 options. 14 on 20 is going to give you 7 on 10. And similarly, so that's where that answer is coming from there. Greater than 4, less than 7, it was the same thing. You're just going the other way. The 6s, the 5s, the 4s, the 3s, the 2. You have 14 numbers, so 14 out of 20, which when simplified is 7 on 10. So that's question number 4. Number 6, and this is where it gets, whoa, getting that to fit on the screen. Real challenge there. But this is number 6. So that was your question number 6 that you had to work on. Question number 6 is there. So if you wanted to look at it again, or you need to look at it if you're not happy and you're thinking where you made a mistake, you can come back and freeze the video here. So let me go back out there. Right. So question number 6. That's the first bit was asking you to complete the tree diagram, copy and complete the tree diagram, and put in all the probabilities. So that's what you needed to do. You were given the 3/5, so adding 2/5 for tails, because all the probabilities in every branch should add up to 1. Every probability in the branch, because it's either you're going to get a head or a tail. And if the chance of getting a head is 3/5, then the chance of getting a tail has to be 2/5, because one of these outcomes is certain, and the idea of certain means we need to sum to 1. That's in the first toss. The second toss, after getting a head, you either can get a head or a tail. This branch has to add to 1. Similarly, after getting the tail, this branch has to add to 1. Each branch on a tree diagram must always sum to, when you add the branches, they should always sum to 1. If you want to say each one of these set of triangles, or if it was 3 options, you would have something like this option. I should have that branching out and adding up to 1. Okay. That's a big idea there. So hopefully we're fine with that. As usual, if that's not the case, you want to get in touch and we can go deeper and explain things more if necessary. Last bit of the question, part B, was asking you to use the probabilities to come up with answers. What's the probability of getting a 2 9/5? 2 heads, sorry. So head. For B, you were following this pathway, head. I want a head and a head. Recall when we use the word and, it means to multiply. So that's how we're getting 9 on 25 when multiplying the fractions. At least one head. That was for part 2. So that was head tail, or tail head, or head. Those 3 options are the ones that you were considering, which gives you 21 on 25. The other way of looking at that for number 6 was to ignore all. So for part 2, what you could have thought of all but tail. So all the probabilities except tail. So you could actually just take away 4/25 from 1 to get to 21 on 25. So that's another way of looking at that one there. Let's see. So we're fine with that. I'll just take that off there. And any other comment? Exactly 1 tail. Exactly 1 would be the 2 in the middle. So exactly. Actually, I wanted to put the options here. Yeah, I'll leave that. Head, tail, head. That was for the second one. For the third one, sorry, the last one was exactly 1 tail. Exactly 1 tail would be head, tail, or tail, head. So we needed to add 6 on 25 and 6 on 25. That's the logic there. And then finally, for 2 tails, I should have done that first. That was tail, which is this option here for 25ths. So those are your answers there for number 6, head. And I think that this question gives you a good sense of what a typical tree diagram question could be up to, that if it's pitched at about grade 5 level. This is what it would look like. Moving on, number 8 was another big one, and this time they didn't give you the framework for the tree diagram. So number 8, that's what it looks like here. I've just brought it in. That's number 8, and yeah, let's look. So both cards are royals, one card is royal, etc. You had to build a whole tree diagram based on the idea of 15, and royal is king, queen, or jack. Okay, so you needed to build all your probabilities, etc. And your starting point actually would have been a probability of a royal card would have been now what we're putting here, the chance of getting a royal is 3 on 13. Where has that come from? Because you have 4 suites. Remember, it's the diamonds, the spade, diamonds, hearts, the 2 red, diamonds, hearts, spades, and clubs. Each have 13, 13, 13. In terms of royal cards, in terms of royals, they would have 3, the jack, king, and queen. three royals, three royals, three royals. So in terms of the whole 52, yes, you could put 3 3 3 3 12 on 52, but actually looking at how I've framed it here, it's actually the same thing because you have the same number of each suite of cards, the same as three. It's the same as 3 on 13. So 3 on 13 royals. And then if it's not royal, it'll be 10 on 13 because it, again, that idea, it has to add up to 1. So 10 on 13 is what you'll get there. Continuing that pattern because, well, what card you get, because you're putting back the card, critical word they had in the question, so important, they said it is replaced. They said that it is replaced. That makes all the difference there. It means that the probabilities will remain the same in terms of your chances to get the second card. And once we have those and we build the probabilities, the probability of getting a royal and a royal, so this is royal, royal, this is royal, not royal, this is not royal, royal, and this is not royal, not royal. So those are the 4 probabilities that you would have had. They asked you then the probability of getting a royal and a royal, so that's the probability royal and royal was part A, so 9 on 169. We're just multiplying the fractions because we're using the word and means to multiply. Then for part B, 1 royal card. What's the chance of getting 1 royal card? The only way you can get 1 royal card is if you get not royal, royal, or royal, not royal. In each of these combinations, you only get 1 royal. And note they didn't say the language there was 1 card is royal. Has to be 1. They did not say at least 1. They said 1. So that's the difference between this and question 6. One of the questions in question 6. Language is so important in probability. So not royal, 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 not royal. And that is why we add these 2 probabilities. It is, and why we're adding is because we're thinking of the language or. There are some tasks I'll do where we'll talk more formally about this language, and when we'll try and formalize some probability terminology, the idea of an independent event, an event when something doesn't depend on what happened before. So in this case, what happens for the second card is not dependent on what happens based on the first card you pull. So it's an independent event. We'll deal with that as a separate lesson, separate task at a later stage. And then mutually exclusive. That's another key piece of probability language we'll deal with in another task. And that's where the idea of or comes from. Mutually, we can use for mutually exclusive because it's the idea that these 2 things can't happen when 2 things can't happen at the same time, mutually exclusive. We'll look at that addresses the idea of addition. When mutually exclusive, it's either, for example, a head or a tail. You can get a head or you can get a tail. You can't get a head and a tail on a coin at the same time. So we'll deal with those terminologies at a later stage. Continuing on this one, so we added. Part C was asking at least 1 card is royal. Now it's different. Because they've said at least 1, we can include royal, royal, not royal, royal, not royal. And 2 ways of doing that. We can add up all these probabilities. Numerators 30, 30, and 9 giving 69, and the denominator remains the same. Or you could have taken away 100 on 169 from 1. Finally, neither royal, neither are royal, so that's not royal, which is 100 on 169. So those were that's the sense of the answers you should have, or the answers you should have had for the first 4. For the remaining questions, which some might say are the harder ones, yeah, but we don't want to spoil all the fun, and we also want to try and get into some discussion, and look, that's really important. So here are the answers to 11, 12, 13. I'm not going to make any commentary or talk through the questions. You just have these to mark your work. And if there is something that you're not happy with and you don't understand where you made the mistake, then there's that opportunity to get in touch and see where you can go from there. Okay, so whatever teacher, it might be getting in touch with me or any other whatever teachers are working with, whoever teachers are working with you. to help. Discussion is important. 11, 12, 13 there. Pause and you mark your work. Then, yeah, 14 and 15. You have 14 and 15 here. Look at 15. Exciting. Look at those decimals. Wow. Yeah, okay. So pause and mark your work there. And note 14, it's interesting the fact that they have provided an answer, potential answer as a percentage or a decimal. Um, the other bit I would mention is for number 14. This is a big one, so I'll just slip it in here. An image of it. It's number 14. That diagram. Okay, it's not mentioned here, the name of the diagram, but that is a diagram. It's called a Venn diagram. That we're going to be doing a lesson specific on Venn diagrams going forward. Very, very important tool that you need to understand and make use of. So Venn diagrams, that's going to come up in a session. And that's 14, 15, and then 16, 17. 16 was huge, so that's the solution for 16 to mark your work. Very big one there. And lastly, whoa, yeah, 16. I think it's probably when I saw question 16, I decided, well, not going to get that on the screen. Not going to happen. But with some work, I can do it. But time, got to balance the time, yeah, to do these things sometimes. Right, and number 17, that's your answer for number 17. Wow, that was a big one. Look at that. This was like, yeah, how did you, if you mastered this, you should be, this deserves a dance. If you were on top of this one, that definitely deserves a big dance. So that's 17, and that's it. We'll stop there. So you have all the answers to task 28. I've done went through, made some commentary on the first four. These are the big ones, which if you want to have commentary, then message and message the relevant person, the appropriate person in your case, and see how you can get support there. Okay. Yeah, we'll stop on that, and yeah, be more tasks to come. More tasks to come.